So yeah, so basically I call it 1 million games of Go because the game's been out for about 18 months and we've facilitated about 1 million player versus player games, all of them powered by GraphQL. And my general impression is that it's a great technology, and any system that I build going forward today, I'll probably make use of it. But sort of in the time, in my sort of battle experience, I've encountered a lot of pitfalls and tricks. And so in this talk, I am going to sort of share with you my experience integrating GraphQL with this game, and so share some of the ups and downs of that. So I think it's very important to understand fundamentally what GraphQL is and is not. It's sort of, I consider it to be a type-safe layer that sits on top of a REST API that gives you a very well standardized request response protocol. So in any case where I would previously use a REST API, I think GraphQL is a superior replacement, and it gives you everything REST gives you, plus it gives you this type safety on top. Now, it also addresses some server-to-client messaging through subscriptions, which I'll get into later. And it doesn't directly include any kind of authentication or authorization component. It kind of assumes that you're doing that through a separate mechanism. But it's pretty simple in that your request would generally carry an authentication token, and that you would use some other system to authorize requests. By the way, I have included some examples here that are sort of GraphQL pseudocode. This isn't meant to be executable code. It's just meant to sort of sketch out ideas that I'm talking about. So it's also important to understand what GraphQL is not, because there's a lot of hype around it, and I think the hype overstates how powerful it is for certain things. And you have to understand that GraphQL is not meant to be a distributed state synchronization system. Like, it is not going to magically sync up the state of your objects between a client and a server or different clients. It is still up to you to design protocols to handle things like side effects and concurrent updates. So I have this user object here that has like an ID and a username. I'm going to use this in a couple of examples. And beware of the hype that suggests, if you define this user object, then magically all of the clients and servers that deal with user objects will somehow magically stay in sync. That is not true. GraphQL gives you a very solid request response protocol, but it does not give you sort of automatic universal synchronization of all your objects. And so I'll be talking about this theme a bit, because particularly for a game, there's a lot of state to synchronize, not just users, but also the game board, the scores, things like that. And one of the key issues in game development, and also app development in general, is how to synchronize state between different clients and between the client and the server. So on the client side, I use the Apollo library. Apollo publishes GraphQL clients in many different languages. My client is in React Native, but you can use many different choices there. One of the best parts of Apollo client is its cache layer. The Apollo client cache is really magic, and it can take the role of propagating updates to objects throughout your client in a very nice automatic way. So as an example, this is some like React pseudocode that is basically displaying information about a user in a user interface. So it has a GraphQL query that queries the current user and gets their ID and username, and then it displays in the UI, my name is so-and-so. And if you follow all the rules, which I'm about to talk about, this reactive UI will update automatically. So if you perform an operation or receive a notification that the username has changed, this UI will automatically stay in sync and update that username without any further code to write, which is really wonderful and revolutionary in that normally when you use a REST API, you would have to have all sorts of callbacks and handlers and subscriptions and just write a ton of code to make sure that the UI display stays in sync with your system's idea of what the state is. And the Apollo cache can actually propagate those updates automatically as long as you follow a couple of rules. So the key rule is that all of your GraphQL objects have to carry an ID field. This is the key inside of Apollo's cache. So when I've been defining the GraphQL APIs for my app, essentially every object has to carry an ID, even things like, let's say, chat messages that maybe ordinarily wouldn't have an ID on them. If they're missing an ID, then this whole Apollo cache business doesn't work. So my advice is all of your objects, no matter how trivial, should carry an ID field so that the Apollo cache can do its magic in terms of snooping for any updates it sees, like whether it's an operation that you're performing or a subscription update that's coming in. If Apollo sees a new version of an object or a new version of some property, it will automatically apply that throughout your whole app based on that ID tag. And at the bottom, I should note that when this fails, debugging can be non-trivial. So what I'm talking about is sort of very magical. It's all happening behind the scenes without you writing code to make it happen. And when it works, it's wonderful. But when it fails, like for instance, when you perform an operation and somehow the result does not automatically propagate through the cache, it can be very difficult to debug what is going on. There are some tools to help with that, but I've had a couple of cases where I had to spend a lot of time figuring out exactly why Apollo was not doing its magic on a particular object. So one thing to keep in mind here is whenever you perform an operation that's going to change the state of an object you care about, you need to ensure that the side effects from that operation come back to the client. So as an example, if we have that user object and we offer an operation to change the username, it's essential that somewhere in that operation we retrieve the new username. And you can see in this example here, the set username GraphQL method is going to return a new copy of the user object showing the update that you applied to it. And so this mutation asks for the username of that new user object. This is key so that Apollo's cache in your code will see the result of that mutation as soon as the response comes back from the server. So you've got to understand what side effects each of your methods have, and then ensure that you're querying for that new data in the mutation that goes out to the server. So the safest way to do this, as I call, is just return the thing you just modified. So if you have an operation that modifies a user, you make sure that the user is returned by that operation, which always works. It has a drawback though, which you can sort of over query. And then if your user object is very large and heavyweight, it means that every single operation that touches that user is going to be performing, those heavyweight database queries to get the data. And so that's sometimes undesirable. There is an alternative way to do that where let's assume that we're using a different version of set username here that does not return the full user object. So this is a more lightweight operation that's just going to return maybe a Boolean value of success or failure. You can still retrieve the side effects, but what you have to do it explicitly. So in my change username mutation here, I've now broken it down into 2 steps. The first step says set username. And then the second step is actually a sort of query that says, okay, after you've set the username, now get me the user again and make sure to send me the username property so that I receive the side effect of that update. I've been using this pattern more and more in newer code because it means that each individual mutation does not have to return a big heavyweight object, but you still get all of the side effects back in a single response to the client. And I hesitate to use the word atomic here because these 2 steps are not atomic in the sort of database sense, but they are atomic in that the response is going to come back to the client simultaneously. So from the point of view of your UI code, these 2 operations are sort of grouped together in an atomic package. And so this is a good way to receive the side effects of an operation. Now, one thing, there's a limitation in the GraphQL spec where a request must either be a mutation or a query, but it cannot include both, I believe. And so and you'll notice here that this mutation bundles 2 things. It bundles an actual mutation operation, but then it bundles a kind of query with response. And what I've had to do is actually define for all of my queries a mutation version of that query that does the exact same thing, so that I can do this sort of bundling into these atomic request responses. And I think that's kind of an odd quirk of the GraphQL spec, but it seems to be working pretty well so far for me. Another thing to keep in mind here is ordering of messages, and this gotcha hit me quite a bit as I was writing the game code. By default, the Apollo client has the freedom to reorder requests. So if your UI code here says like set username to A and then later set username to B, there is no guarantee that the server will see A before B. It may see B before A. You can, there's an extension to the Apollo client that you can use that will serialize requests on the client side. But even if they're serialized on the client side, there's no guarantee about the server processing. So your set username A could go out on the network first, but it could take a while to process. And in the meantime, your set username B goes out and the response comes back, and then the response to set username A comes back. So request ordering, if your app cares about the order of requests, you need to manually use some other technique like like a timestamp or a incrementing message ID or something in order to reorder things. GraphQL is not going to handle this for you. And so this creates a few issues. One is that if you have, let's say, a toggle switch in the UI, and whenever the user clicks that switch and turns it on or off, it fires a GraphQL request. You're going to see odd things where the toggle switch is going to kind of flip by itself because the message ordering is not well defined, and you can have the client say turn it off, and then a response comes back to the client from the server that says, okay, you just turned it on from a previous request, and the toggle switch will flip. So you have to fix this by debouncing, and the simplest way to do it is to just have a sort of in-flight state where the user has clicked something and the request goes out to the server, and during that network request, you kind of gray out the UI and say you can't show a loading indicator or something until the response comes back. That's what I tend to do most of the time. However, in certain operations, very latency critical, and the user will find it bothersome if the UI is constantly blocking for a network request. And so the Apollo client does allow you to do what they call optimistic responses, or from the games industry, we call it client-side prediction, where you kind of assume speculatively that the operation succeeded, and you apply the result of that operation instantly into the UI. So from the user's point of view, it looks instantaneous. You have to be very careful here about conflict resolution, in that if the request doesn't succeed, or if some other previously in-flight operation comes back with a different response than your code expected, you're going to need to write code to manually resolve that conflict. And the Apollo docs go into detail about this. It's one of the trickiest parts of writing a GraphQL UI, I've found, is trying to make it sort of instantaneously responsive, but also handle all the cases of either a previous client request is updating something, or the server wants to update something, and kind of resolve that in a clean way. And at the very bottom, for any operation that's super critical, where the ordering is absolutely critical, and you have to resolve contention between let's say different users that are trying to update the same object, then you have to use a more heavyweight synchronization method like a vector clock or a CRDT data type. So, there's a lot of literature out there on good ways to do this, and you can use those ways. Just keep in mind that GraphQL isn't handling this for you. It just gives you a request response protocol, and it's your responsibility to build your sort of synchronization system on top of that protocol. Just a quick note here on error handling. There's sort of two ways to go in terms of the schema. You can either have operations explicitly have a return code, or you can go in more of like an exception handling method, where there's there's an out-of-band exception that can be attached to GraphQL responses. So that decision is sort of at the schema layer. And then there's also another decision within the client code itself. So Apollo gives you a choice of, when a response carries an error, you can choose to either kind of receive partial data, in that the operation, the function call to run a query or mutation still returns a result, but that result may be null or have nulls inside of it. Or you can configure Apollo Client in a different way to actually just throw an exception, like a JavaScript exception, when it receives a response that carries errors. So that's up to you. In my own code, over time, I've headed more in the direction of using explicit return codes as opposed to throwing exceptions, both at the GraphQL schema layer and inside of the Apollo client code. The reason for that is, one, I found that errors are a lot more common than I expected, especially when you're dealing with a mobile client. Networks are extremely unreliable and clocks get out of sync all the time. And so, in the back-end world, there's all these, it can't ever happen type errors, but that they become pretty common when you're dealing with a mobile client. And so I prefer to have explicit handling code for cases like that. Very often there needs to be some sort of UI pop-up message like, error, your clock is out of sync, or, your network failed, press here to retry. And so it's generally, I've found it better to have explicit return codes. And at the bottom, I've sketched out how I do that in the GraphQL schema. So for a mutation, like that set username mutation, instead of returning the updated user object at top level, it returns a little object that contains a success Boolean, a code that sort of represents an error code, and then also the updated user object inside of it. And I found this pattern to be a good one for operations that that can possibly fail and need to carry some error data. One last tip on the client. The GraphQL spec doesn't say much about the maximum size for integers. So I like to use epic timestamps to store time values, which can grow bigger than 32 bits. And I've encountered problems with certain GraphQL clients not being able to handle large integers. So anytime you have a potentially greater than 32-bit value in your schema, I recommend passing it as a string. It seems wasteful, but it's the safest way to do it that I've found. I also want to talk briefly, this is the sort of the last slide on the client side, about AWS Amplify. So AWS bundles together many of their libraries together with sort of a patched or hacked version of Apollo client and calls it Amplify, and they have all this documentation about how Amplify makes it easy to write mobile apps that use GraphQL. So I do use this on the client, but I'm not very happy with it. One issue is that it handles the authentication and authorization for you by integrating with AWS Cognito. However, I found that code is rather unreliable, especially on a mobile client, because they don't take into account things like network issues, timeout reconnect behavior, and also token refreshing. I found that code to be very shaky, and just in general, the AWS Amplify client code is below my expectations for code quality for AWS. And so I'm moving in the direction of just dropping this and using the plain Apollo client instead. Okay, so now I'm going to switch from talking about client-side things to talking about the backend, which in my case, I'm implementing with AWS Appsync talking to a Lambda. So Appsync is a managed GraphQL service that AWS provides. I could use alternatively something like the Apollo server in like a Node.js Express service or some sort of Java-based service. But Appsync is wonderful when you're just starting out with GraphQL because AWS takes care of so much of the boilerplate. You can just hook up Lambdas to your queries and mutations. So I manage this with the serverless framework, and that's serverless with a capital S, like the actual open source project called Serverless, which I found to be wonderful. It takes care of updating the schema and the Lambdas in a very nice, seamless way. So basically the way I built this backend is, the majority of GraphQL methods, whether they're queries or mutations, they just map one-to-one with Lambda calls. One mutation becomes one Lambda call. But what's nice about Appsync is it gives you the flexibility to shift things around, particularly for backwards compatibility. So as an example of that, let's imagine we have that user object here where it's got an ID and a username, and then we make a version 2 of this where in our new client, we want the usernames to be able to have like bold-faced text or emojis or something that we can't represent in a string. So we come up with a new version of the username called fancy username that is some sort of advanced, like rich text object. But we still need to support legacy clients that expect to see that plain old username string. So we include both of those in the GraphQL schema. And then what we can do is the primary user handler only needs to return the new stuff, so the ID and the fancy username. And then we can have a special purpose resolver that exists only to serve legacy clients. If a legacy client, in this rare case, still asks for that old string username field, you can write this little compatibility resolver that will first query the user using the new data format, and then emulate the old schema by extracting like a plain version out of that fancy username. And the nice thing about this is your handler code can be doesn't have to have a lot of backwards compatibility junk in it. Your handler code can basically be switched from version 1 to version 2, and then you can have an extra little piece of code off to the side that's your backwards compatibility handler that deals with the legacy clients. Another issue here that happens a lot with mobile clients and also with Lambda is that it's very common for requests to be duplicated. And this can be because there was a network failure somewhere and the client thinks that its request failed and so it sends a retry. Or Lambda itself actually doesn't guarantee that it's only called once. It guarantees that it's called at least once. So it's very common. Let's say you have an operation that says like create object and you give it a string for an ID of that object. And then let's assume the IDs need to be unique. So if you create an object called foo and then you try to create another object called foo, that's actually an error. Well, that is going to be awkward in this backend because very often you'll receive 2 requests in a row for the same thing. And then the first one will succeed, but the second one will fail. And from the client's point of view, it's going to look like it's one and only request failed, which isn't actually true. So you need to make sure that all of your API is idempotent and it kind of gracefully handles these duplicate requests. So for example, if you're writing the handler code for that create object mutation, you can first try to create the object, but if that fails because the object already exists, don't consider that an error. Just return that existing object as if you had just created it. So from the client's point of view, it's going to look like that create object succeeded, even though it was a duplicate request that actually didn't do anything. And doing this throughout my API has been really helpful in terms of cleaning up errors. I used to have a ton of issues that looked like inconsistencies between the server and client that really just came down to duplicate requests and needing to handle them in an idempotent way. One note on Appsync particularly, that Appsync adds a very large amount of latency. Whatever AWS is doing internally in the Appsync layer is very heavyweight, and I've seen anywhere from like 100 milliseconds to 400 milliseconds be added to requests between the client's network message coming in and the Lambda. So for a game, that's actually a pretty substantial penalty. And in fact, that's the single largest source of latency in our whole stack. It's just the Appsync layer. Another tip is that by default, Appsync has some very comprehensive logging, which is great for debugging, but it's very, very verbose, and you'll end up spending a lot of money on CloudWatch. Also, if you turn on tracing, which is also nice for debugging, you'll end up spending a lot of money on X-ray. So I'd recommend having a toggle switch where you can turn logging and tracing off or to a less verbose mode most of the time, and only turn it back on in full mode when you're actually debugging an issue. A couple other issues with Appsync. Appsync uses a non-standard WebSocket protocol for GraphQL subscriptions. Unfortunately, the spec isn't very detailed about the actual like HTTP transport layer. So Apollo server does it one way and Appsync does it another way. There are patches out there. There's a community patch out in GitHub that adapts between Apollo and Appsync, and we use that. It works pretty well. But there are still some issues around token renewal for long-lived sessions. This has been an issue with like Cognito and Apollo and Appsync, that they just don't handle very well the case of a mobile user who uses the app maybe once a day. And so hours and hours and hours pass between sessions of your app. And very often your, whatever authentication token you have will expire during that time. And it doesn't do a very good job of kind of seamlessly renewing and recovering from that situation. Another quick note on sort of local testing. Of course, Appsync is, updating things in Appsync is very slow. And so I wouldn't recommend doing your sort of local development and testing with the actual Appsync service. There's a nice third-party emulator that lets you run local test code against a little Node.js service that pretends to be Appsync. We do use that, but one thing to keep in mind is it's not maintained, nobody's in charge of it, and there are cases where its behavior is different from the actual Appsync service. And so I've been caught a few times where my code passes all the tests because it's talking to the local emulator, but when it goes up into the real Appsync, that different behavior catches us off guard. And like final note is that, for authentication, we're using Cognito. It's nice that Appsync sort of takes care of that automatically in the background. But Cognito itself has a lot of problems and I'm not very happy with it. So eventually we're planning to migrate away from that. So we got to the end here, and this is just things I want to do in the future to make our GraphQL integration even better. One big one is to automatically generate language types based on the GraphQL schema. So if you imagine you have your GraphQL schema with that type user with an ID and a username, let's say you're writing JavaScript code or TypeScript code that interacts with that object. You need to have a TypeScript definition that describes that type. And for now, I've been writing all of these manually. Like every time I introduce a new type into my GraphQL schema, I have to manually write out the equivalent, JavaScript type. But there are tools that will do this automatically for you. And so I'd love to have, to integrate one of those tools so that the language types are automatically up to date with the GraphQL schema, and that everything can be type checked, like all of the return values, all the parameters, query variables can be type checked. And finally, I mentioned that Appsync has a lot of drawbacks, and it is nice early on when you're prototyping an API, but using it in production has drawbacks. And so my plan is I'm going to be replacing it with a kind of sort of bare metal service where we'll probably use the Apollo server libraries running inside of a Node.js Express HTTP server, and then just run that in a Docker container and use that instead of the Appsync plus Lambda setup that we've got now. That's mainly about reducing latency, also about reducing cost. And I think we'll be happier with that solution down the road. But it's gonna take some effort because we do have to, we want to remove the dependency on Cognito. We want to take over handling authentication ourselves. And another thing is that Appsync provides an automatic sort of publish subscribe system when you're doing GraphQL. I haven't talked about GraphQL subscriptions, but basically they require a pub sub service so that you can propagate messages that originate on any of your GraphQL servers down to any GraphQL client. And you'll need to come up with some replacement for that, which I think may rely on SQS. Still want to keep it managed.